Okay, chemical reactions and equations. So the bulk of this unit is going to be writing reactions and predicting what products they'll make. There are 5 basic types that we'll be talking about, but before we can do that, we have to refresh our memories from junior high, probably, of how to balance equations. Okay, some of you probably did great at balancing an equation in junior high, some of you maybe not as much. However, tend to do much better at it in high school, A, because you have been doing chemistry all along, and B, you've got more practice under your belt. You have tried harder things since junior high, so your brain process works a little bit better. Okay, so here we go. First of all, properly written equation can summarize any chemical change. The following requirements will help you read and write chemical equations. So, number 1 is going to seem pretty basic and pretty like duh, but I literally have people ask me this every year, so I put it in the notes. The reactants are before the arrow. The products are after the arrow. Because I'll tell someone about your reactants, and they're like, which one are those? So I know it's basic, and I know it seems very elementary, but every year I get asked that, so I decided to add it in. It is the law of conservation of mass and energy. It already says and energy. Yeah. It's the law of conservation of mass and energy that must be satisfied. Okay. Quite frankly, in chemistry, we care a little bit more about the law of conservation of mass, but the law of conservation of energy is also conserved. In other words, we cannot create or destroy mass or energy in these equations. Okay. The mass is going to be rearranged. Maybe we might lose some gas, but if we were in a closed system, that energy would be conserved. Okay. Energy, it's not that it's lost, it's that it's sometimes converted into an unusable form. Okay. Therefore, the same number of atoms of each element must appear on both sides of the equation. In other words, if I start with 5 carbon atoms, I better end with 5 carbon. They may not be arranged, most likely they're not going to be arranged in the same manner, but I still have to have 5 and 5 on each side. Okay. The state of matter should be indicated for each product and reactant. We're going to show you how to do that in a second. Remember your Brinkelhoffs when you're writing these equations. That bites some people all the time because they forget that when I say hydrogen gas, how should I write that formula?
H2.
H2. Okay. They are diatomic only, what do I have written in bold?
When they are alone.
When they're by themselves. If they are in a compound, they are not bound to their diatomicness. Okay. For instance, what is the formula of water?
H2O.
H2O, just one oxygen, even though oxygen is one of your Brinkelhoffs. They're only Brinkelhoffs by themselves. Sometimes people get caught up on that and they think, oh, but it's a Brinkelhoff, it's got to be Cl2. No, it doesn't. Okay, it has to be what it needs to be to bond. Okay, and then all chemical changes are accompanied by some form or some change of energy. We have the release of energy and we have the absorption of energy. Would anybody care to tell me what the release of energy is called? Starts with an E.
Explosion.
Exothermic, not explosion, although an explosion is exothermic. So exothermic releases heat, and so we feel it as getting warmer. And then endothermic is absorbing heat from the surroundings into the system, and that one will feel like it gets cooler, and that is endothermic. Okay? So now let's talk about the things that we'll see in an equation, which is this nice little list. All right, so if it separates the products, the 2 or more products from each other, we just write a plus sign. Easy enough. Hydrogen plus oxygen yields, that's the next one, water. So when we see that arrow, it doesn't say equal to, it says it yields. Okay? If it's a reversible reaction, we do a double-headed arrow. Means that under certain conditions it can reverse back and go back. So water, the formation of water is a reversible reaction. I can reverse it and get back my hydrogen and my oxygen. Okay. Do what?
Reverse osmosis.
Not quite the same, because osmosis itself isn't a chemical reaction. It's just the migration of concentration. Yeah. So to designate a product or a reactant in the solid state, we do the little parentheses and we draw a little S. And those are usually written kind of as subscripts, so real kind of small. An alternative to writing S is if a product is produced, so this would be only for a product, we can show it as an arrow going down. That's not a very good arrow, sorry. The reason being is if I form a precipitate, which is a solid, what's going to happen to the solid in the liquid? What's it going to do? Sink to the bottom. Okay, so we can show that as an arrow going down, like, oh, I formed a precipitate. Okay, liquid we do as an L. I will write it as a cursive L only because if I don't, you think it's a 1.
Why don't you just do a capital L?
Because we usually use lowercase. Yeah. Usually in a textbook or whatever, they'll do like a italic L. I can't really print an italic L, so or maybe I can. Here we go. L. Oh, yeah, I'm going to start doing that.
That looks like a 2.
I'm going to stick with my cursive L. Okay. We already recognize aqueous, right? How do I do aqueous? AQ, because y'all kept asking me, what does this AQ mean? Aqueous means it's dissolved in water. So if I were to take a solution, if I were to take salt, NaCl, and I dissolve it in water, I would write NaCl, and then I would say AQ behind it, which shows me that that's not just like salt crystals, it's salt that's been dissolved in water. Okay. If it's a gas, what do you think I use for a gas?
G.
G. Y'all are so smart. In parentheses, yeah.
Well, you
So you
always
don't
write it
think
in
it's like
parentheses.
an element or something?
Yeah. Well, yeah, and it's usually subscripted too, like if you're reading an equation, okay? Some teachers get caught up on this and they want you to put states of matter on everything and they take off if you don't. The AP exam doesn't do that anymore, so I don't emphasize it quite as much as I used to, because if they don't emphasize it in AP, I'm going to move on and not worry about that as much. Yes, ma'am.
Well, so like for the arrows, the down arrow and stuff, would you also put that as a subscript?
So let's say,
To the thing that's a precipitate.
yeah, so let's say that I did a reaction and I formed silver chloride, which is not soluble. I could draw it like this to show that it formed a precipitate. Or I could do the S, either one. Okay. An alternative to G, but again, only if it's a product, meaning it formed the gas. What do you think it is?
Diagonal arrow.
An up arrow. Why diagonal? You're just being difficult. That'd be an up arrow, because if I form a gas, what happens to that gas that's in the liquid? It bubbles up and escapes. Yeah. Okay. And then if I have to supply heat to the reaction, I'm going to show that by drawing the arrow and drawing a little triangle over it, which shows that that reaction was heated in order for it to happen. Oftentimes a decomposition reaction, you heat it and it decomposes back into its original original element, so we show that by showing that little triangle. If it's something that required a catalyst, same thing. I'm going to draw it down here because I'm running out of room. We draw the arrow and then we would like list the catalyst over it. For instance, platinum is a very common catalyst. Sometimes it can be a compound that's a catalyst, MnO2. In the case of photosynthesis, what is its catalyst? Enzymes are not the catalyst.
Enzymes are biological.
They are biological catalysts, but they're not the catalysts that make photosynthesis happen.
It's the sun.
You wouldn't draw the sun, you would say sunlight or light, but I'm trying to give you a hint. Yeah. So that's what you would do, because the sunlight is the catalyst that makes the CO2 and the water react to form glucose. Okay. Without sunlight, do we get CO2 and water reacting to form? No. But sunlight is the catalyst. It's not used up. Okay. Whenever there's a catalyst, it doesn't participate in the reaction. It just helps it get there quicker. Okay. All right. So with that being said, let's move on. Okay, so just a reminder of your Brinkelhoffs. They're the diatomics. We write them as H2, Br2, all that stuff. We're not going to worry so much about sulfur and phosphorus being polyatomic. I will mention it real briefly. Sulfur is usually S8. We did? Oh, there was enough. Awesome. And then P4, thank you. P4 is phosphorus. You do not have to do them that way. You can just use S and P. But if you saw it somewhere, I didn't want you to be confused. I think on your worksheet today it shows up as S8. And so I didn't want you to be like, what? I don't usually hold y'all to that, but that is, in fact, polyatomic instead of diatomic. Okay, so we are going to write and balance these equations. First things first is you have to write your formulas correctly. Okay? Once your formulas are written correctly, you do not change them. Okay? If you are still struggling with writing your formulas correctly, this is going to be a difficult unit for you.
What do you mean formulas?
Like if I told you sodium phosphate, that you would be able to write Na3 PO4. So that's writing your formulas correctly. But here's the thing. Once we have our formulas written correctly, we do not change them. We will only balance our equations usually using the coefficients in front of them, the big numbers in front. That's the only way that we can do that. And here's where I make you take an oath. Are you ready? Raise your hand and say, I do so solemnly swear.
I do so solemnly swear
That I will not change the subscripts
that I will not change the subscripts
in a correctly written formula,
in a correctly written formula,
and I will only balance the equations
and I will only balance the equations
using the large coefficients.
using the large coefficients.
Okay, thank you.
Sometimes.
Because what happens is people see, oh, it's SO4, but I only need SO3 over there, and then they change it. And then you've changed the compound, okay? So if you are having trouble balancing the equation and you wrote the formulas, you should go and check to make sure you wrote them correctly. But if you know without a shadow of a doubt that that formula is written correctly, do not change it, okay? You use the coefficients, okay? So we're going to do an atom inventory, and then we use those coefficients to make that balance, okay? Now, in junior high, they probably had you list them out. If you want to do it that way, you can, but it's way tedious, okay? So just to make sure that we understand, we're going to do one little quick one together, and that is the 3Na3PO4, sodium phosphate, okay? You multiply the coefficient times the subscript. So in that particular one, how many, right here, how many sodium atoms do I have? 9. You multiply. It's okay. How many phosphorus do I have?
Wait, 3.
3. And how many total oxygen atoms do I have? 12. Okay? Does anybody have a question about that? Okay. Do what?
I was trying to copy that, but it's different on my end.
Yeah, that's why I was.
The first one should be on there. There's other ones on there, but we only practiced the one.
Na2SO4.
Oh, it's Na2SO4. It's a different example. I apologize. Yeah, I apologize. I fixed earlier today an error in the notes on the PowerPoint. I didn't catch that one. Y'all are the first ones that have said, oh, it's not the same. Same concept, though, right? Okay. The important part is the equations they're going to be the same. Okay? All right, so let's practice. First one is the decomposition of water, H2O breaking down into H2 and O2. So people ask, what's the first thing I should balance? And I say, whatever you notice first. Okay? Some people will tell you balance the metals first, balance this. I say whatever you notice, balance first, because oftentimes when you balance one, it kind of takes care of another one for you and you don't even have to worry about it. Okay? So in this case, if I first look at hydrogen, it's balanced, but oxygen's not. Okay? So I have 1 oxygen on the reactant side and 2 on the product side. So the only thing I can do to fix that is to put a 2 in front of water. So now I have enough oxygen, balance my oxygen, but now I'm not balanced on my hydrogen. But that's an easy fix, right? Because now I'll just put a 2 there. So I have 4 hydrogen on both sides of the equation, and I have 2 oxygen on both sides of the equation, so I am balanced. Okay? How about that next one? I want to give you a hint. When you see those polyatomic ions, like nitrate, balance them as a unit. Don't try to balance them as nitrogen and oxygen separately. It makes it much more difficult. Balance the whole thing. Because if you balance them and there's the same number of nitrates, then there's going to be the same number of nitrogens and oxygens.
Just B, we're only doing B right now.
We're in the middle of a lecture. Your hair looks nice, May.
Were you all in the middle of the test?
No.
No.
Okay. So, like I was saying, you want to balance the nitrates as one unit instead of separately. So that's the first thing I notice in this is that my nitrates aren't balanced. Okay? I have 2 on the reactant side and only 1 on the product side. So it's a very easy fix. What am I going to do?
Put 2
I'm going to put a 2 right there.
on the sodium.
So then what happened to sodium?
You need it.
I got to put a 2, and now is everything balanced?
Yeah.
Let's just double check. I have 1 lead on each side. We're good. I have 2 nitrates on both sides. We're good. And I have 2 sodiums.
Do we have to put anything if there's a 1?
No, because the assumption is that you wrote it down, so there's at least 1. Because if there wasn't at least 1, would we have written it down? Yeah. Now, if I were to give you this equation and say, give me the coefficients that balances correctly, you would, in order, say 1, 2, 2, 1, like that. But in terms of when we're writing them down, you do not need to write the 1. Yes?
Where did the sodium come from?
It's just a reaction. I put sodium in the lead 2 nitrate. This is a chemical reaction.
Oh, okay.
So this is like I had a little thing of some lead 2 nitrate and I dropped some sodium in there. What happened? And this is what I can predict would be made. Okay? It would be very explosive if I did that too. A lot of energy would be released. Yeah. Okay? All right, now the next one is the ones that's a tiny bit trickier. Okay? These are combustion reactions, and the way that we can recognize combustion is that they all form CO2 and water. Okay? So when it comes to predicting, they're the easiest to predict because they all make CO2 and water. But when it comes to balancing, you have to do a little trick with that. Okay? So what I want you to notice is that this oxygen right here is O2, right? Because it's a Brinkelhoff, it's oxygen gas. Whatever number I put in front of O2, it's always going to be an even number, correct? Anything times 2 is an even number. Do you agree?
Agree.
Okay. So I can never make that one be odd. Okay? Same thing with this CO2. It's an O2. Whatever I put in front of there is going to give me an even number of oxygen. So here's the problem. Water. Water only has 1 oxygen, which is an odd number, in case you didn't know. Okay? So the problem is I have to make that one be even, which means when I'm doing just a hydrocarbon, which means just carbon and hydrogen, I have to make that water be an even number or I can't get its balance. Okay? So I look at my hydrogen and I see what number would I have to put in front of water. In this case, I would have to put a 5. That's an odd number. It's not going to be balancing. So what I'm going to do is I'm going to say, oh, I'm going to bump that up to 2. So now I would put a 10 in front of water. What would I put in front of carbon?
8.
8.
Oh, and then a 5.
Yeah, 4 times 2 is 8. So then I add up my total oxygen over here. I have 16 plus 10 is equal to 26. So I would put a 13 right there. Okay? Now, if I looked at my hydrogen right here, and it was going to be an even number than I put in front of water, then I just leave it alone and balance it. I don't put that 2 in front. But if it's going to be an odd number in front of water, okay, you need to be careful because if I gave you something like this, then that rule doesn't necessarily apply because I have that oxygen right there. This is just for hydrocarbons, meaning carbon and hydrogen. Pure hydrocarbons, okay? Technically, that's a hydrocarbon too, but if it's just got carbon and hydrogen, okay? Now let's write them from formulas, which quite frankly is the harder part. Especially if you don't know how to write your formulas, okay? So I have iron plus sulfur yields iron 2 sulfide. So how do I write iron when it's by itself? Just Fe. How do I write sulfur when it's just by itself? S. Yields iron 2 sulfide. How would I write that formula? FeS. not FeS2. The 2 is telling me that I have a +2 charge on iron, and sulfur is in group 16, so it's a -2. Okay? How about zinc? How do I write zinc? Notice when I'm writing them by themselves, I am not writing charges down. When they are by themselves, they do not have a charge. A lot of times kids want to write the charge with them. When they're by themselves, they don't have a charge. Plus copper 2 sulfate. How would I write that? Close, SO4. Sulfate, 8 is the higher oxygen. And then yields zinc sulfate. How do I write that?
ZnSO4.
Mm-hmm. Plus copper. So how do I write copper?
Plus Cu.
So you just moved them? Why would you do
What? That's called a single replacement reaction. The zinc replaces the copper. Okay? The last one I'm going to let you try, and then I'm going to do these together. Because these are a little bit... Okay. What's the first thing you notice that needs to be balanced? These are not on your paper. Let's just do these together. Okay? These are just practice. We'll just do these together. What is the first thing you notice that needs to be balanced?
Chlorine.
The chlorine. So I'm going to put a 2 right here. Well, what did that just take care of for me?
The sodium.
Sodium. So that's all that needs to be done. It's balanced.
It
Yeah.
also balances the chlorine.
Well, we balanced the chlorine. And when we balanced the chlorine, it took care of the sodium. Okay? You can put numbers on both sides of the equation. One person today got confused by that, and they were making it very difficult. I'm like, no, you have to balance both sides. Sometimes you just need to do a product. Sometimes you just need to do a reactant, but most of the time you need to do both. How about on this next one? Oh, by the way, I'm going to highly suggest that you use pencil today, not pen. Okay? Use pencil. How about the next one? What's the first thing you notice?
Lead.
Lead. So if I put a 3 here, right? Okay. And then I go to the next one. Oh, wait, phosphate's not balanced. Ruh-roh. How would I balance my phosphate?
You put a 2 in front of the first one. Yes? Question.
Okay, but then what did that do to my lead?
It unbalanced it. So you
Which
had
is
to
why
put
we
a
want to use a pencil.
Would you put a 6?
Yes, I would put a 6. What about my 10?
It needs to have a 3.
It needs to have a 3. Now look at that. What did it do for hydroxide?
Unbalanced it.
It didn't unbalance it. It balanced it.
What?
I have 12 hydroxides on both sides.
Oh, you
Oh,
do.
yeah, we did.
3 times 4, 6 times 2, 12 hydroxides. So what looked like it would be hard took care of itself, right?
Now PV. Wait.
Everything's balanced now. 3,
Oh, yeah.
310 on both sides, 6 lead on both sides, and 12 hydroxides on both sides.
It's like satisfying.
It is satisfying. This is why I like chemistry. It's fun. I know y'all don't think it's fun, but I think it's fun. Okay, so one more. Let's do that one together.
Aluminum.
What do you notice first? Aluminum, or if we were British, aluminium.
Where did they get that?
They spell it differently.
Because they like to. Oh, then you can.
It's IUM.
So you can put a 3.
What'd you say,
in front of
Luke?
the calcium.
Put a 3 in front of the calcium.
Put a 3 in front of the calcium. And when you did that, what were you trying to balance? The hydroxides?
Yes.
Yep.
Perfect.
So then
Then
you
you
put
put
a 3
a
on the
3
far
in
right
front
one.
of the calcium.
And then you put a 3 over here, and look what it did for sulfate.
Wow.
Nice.
Took care of it. Give yourselves a hand. There you go. All right.
Pen on the back.
All right. That's where we're stopping.